The use of test instruments is a major element of electrical fault finding. They must be tested prior to their use to ensure complete reliability. For this purpose, a known supply of electricity is available at the electrician's test panel. Most test panels also provide testing for lamps and fuses. The most frequently used test meters are multimeters, insulation resistance testers, and line testers. A multimeter can be analog or digital type, and we'll describe their setup procedure here. First, an analog meter. For easy reference, the setup procedures are listed on the back of the meter or in the user manual provided by the manufacturer. Basically, the two dials work in combination when setting the meter up for any of its functions. Here, the meter is being set to read AC current by pointing one dial to the AC system and the other dial to the values range, in this case up to 1 amp. Voltage is set by the same dial. Here it is set to 600 volts full scale. For testing a DC supply, the dials change function. First, set the DC system, and with the other dial, select the range, as before. The meter can be set to measure the resistance value of a conductor by setting the ohmic system with one dial, and with the other dial selecting one of a number of ranges of resistance according to need. Here also the two dials work in combination. For each range of resistance values, the pointer must be set to 0, while the probes of the meter are held together. Then, if a known value is checked, select the right range and conduct the test. The resistance scale of a multimeter can also be used to pinpoint an open circuit fault in a small component. Here, a variable resistor is attached to the probes of the meter. There is a break in the resistor coil. When the sweep arm is moved along the resistor coil, where the fault occurs, the meter will show a reading. Ensure that the meter is switched off after use. A digital multimeter displays a measured value in numerical readout instead of a pointer indicating the value on a scale. An example here is employing a central dial which is made to point at a particular value range to be tested. DC volts, DC amps, AC volts, and AC amps. In the case of resistance, infinity here is registered as OL. OL stands for overload. The meter senses no measurement which is within its set range. It interprets this as overloading until it senses a load which it can measure. The process of measuring a known resistance is the same as described earlier. Here's another type of digital meter, which employs toggle switches at the side for setting the desired scales and values. These must be pushed in to set the meter to read a desired scale. The number 1 in the display window represents the first significant number without an actual value being measured. The method of reading a measured value is the same as seen previously. When you finish using a test meter, it is advisable to cancel your settings and switch off the meter. An insulation resistance tester is used to monitor the condition of the electrical circuitry on board ship, as well as for fault tracing. On this particular model, there is a battery test as well as ohm, kilo-ohm, and megohm scales. The meter is tested on all its scales before use by connecting the probes together when the meter shows no resistance, or closed circuit, on all its scales. Then the probes are separated and the meter shows open circuit or a resistance value of infinity. Remember not to touch the probes when activating the meter. They will have 500 volts on the megohm scale, in some cases higher. Finally, a line tester, set to test for the presence of 220-volt supply. First, the voltage on the test panel is set. Then the line tester, or a multimeter for that matter, is tested for correct function.